Okay. Yeah. So today we are going to provision Azure resources from the VM. We are taking a one Linux VM. In that we are going to install Terraform, and one of the prerequisite for that is we required Azure CLI also is required. Okay, I have one Linux instance or Linux VM we have. In that I need to set up Azure CLI. Then Terraform also I need to install. Okay, so after I install this, we need to provision the Terraform resources. So if we use the shell cloud shell, automatically we are getting this, but here we are going to use the one VM from the scratch. And what are the prerequisites now? Azure account is required subscription, then Terraform, then Azure CLI we need to enforce. Okay, Azure CLI we need to enforce. So now I'm this is my Linux mission. Okay, I log into this and this is a Ubuntu 24.04. In this, I need to install Terraform and Azure CLI. First, I'll try to install Azure CLI. Okay, say here we have Azure CLI is there. Okay, I'm going to install Azure CLI on this mission. Okay, and which distribution we have is depends upon that OS distribution. If it is Ubuntu, choose apt. RHEL CentOS, we have DNF. Azure Linux, we have TDNF. Like this, we have the different packages. Now, which packager we are using is apt is our packager. Apt is our packager. Okay, so then here we are installing. So I'll try to install this one, whether it will. So this is we're trying to install Azure CLI. They have given one script itself. With that script itself, we are trying to install this. This is around 2.71.0 something. It is installing. So after that, we need to log in to this CLI, because if you are using uh, shell, already we log into the browser. With that itself, we are going to get that one. Okay. So now here, what we need to do? We need to log into like a aged login like this. We need to use. Okay, so then with that we'll we need to use the uh, like uh, and before that I'm going to confirm whether CLI has been installed or not. Okay, so now here we have Python we have, and even shell also, like sorry, CLI also we have 2.7.0. Okay, so now we need to log into this. So now here I use this method. then aged hyphen hyphen version. Okay, so then I need to log into uh, Azure. Okay, so we have the subscription, then Azure login. I'm going to use aged login. So when I use the agent login for the authentication purpose, we have already logged into from the browser, right? So now here they have given one URL and they have given one enter code. With that we can authenticate. Okay, so now here I'm going to the browser. Here I'm entering this device login and I need to enter this code. Say here they will show one code. This code I'm going to, with that it is going to authenticate. I'm giving the permission for Azure CLI also. So now this is we have signed into this. Okay, so then here which subscription we need to use this. Here this is the first subscription we have. Okay, so that we need to, okay, so type a number or enter. Okay, 1 second. Yeah, so one is the here we have one, then aged. So with which login we have login all these here. We are going to use so with this, and this is our subscription ID B80. We have with the ID, right? So this is your subscription ID. Okay, so using this we have login to just like how all these days we log in from the browser to portal, now we log into CLI also. So using these credentials itself, it is going to authenticate. Then we need to install Terraform also. We need to install CLI we have installed. Now I'm going to install the Terraform also. So now on the Ubuntu itself, I'm installing the Terraform. Here I'm going to use Linux. In Linux also we have Ubuntu or Debian. Okay, so then here through apt itself we are adding the packages, all those. These all like in the Terraform, they have given the steps of how to install and verify that GPG key. By default, all the packages like apt install Nginx like this, we don't get all the packages from the repo. We are trying to add those. Fingerprint, all those we are confirming. Then update all these with the new updates we need to update. Then we need to install Terraform. Now here we got the Terraform also. Okay, so this will confirm the Terraform, but I think we are getting 1.11. That's no issues. Okay, so Terraform also has been installed. So now what we need to do is, like here some more CLI level, we need to configure some authentications. We have agent login we have done. Okay, so then here that subscription, we already set that subscription. Otherwise, here I'm going to set that subscription also. Then with the authentication token also, one service account is getting created. So now here we have uh, so here in this, our subscription we need to keep. How to get that ID is AZ account to show. This is the ID. I set that subscription also. Then we are creating a service principal with the with that permissions, all those we are going to give, and we are using that service principal like with the authentications. For that we are going to use it. Okay, so now here we need to replace the subscription ID. We need to replace with this. Okay, so now everything is done. We'll try to create that resource group itself. We'll try to create now. I'll try to change this name of this cloud TF resource group I'm creating. Okay, so now we have the main.tf, but it's not recommended to create main.tf in this itself. Better to create a directory. It's mandatory. We need to create a directory because that is going to become the workspace. Now, like we are in the home Azure user, in this not recommended to initiate. That's the reason I'm creating directory. Okay, so then here we have this main.tf, right? I'm I'm moving to. Okay, I moved that to my Terraform directory itself. Now in this we have the main.tf file. So otherwise you can create a directory. In that you can create that main.tf. Now what we are doing is like we need to initialize that Terraform initialization we need to do. So in this we use the cloud TF resource group and we uses the Terraform provider and one resource we are getting created, that is Terraform wise the name is RG, and from the Azure portal wise it's going to display this resource group name. Okay, so now here this is Terraform init. Okay, so then in this workspace, so as of now, we have only main.tf, but by understanding main.tf, when I initialize, Terraform will understand we need Azure provider, and that Azure provider it is going to download. Okay, so now here we have Terraform init. Okay, so now Terraform has been successfully initialized. Okay, so then it's downloaded the Azure RM provider also 3.0.2. Okay, and it's created one log file also. Minimum it need to take care that Terraform 3.02 itself, that log file is going to specify. If I use ls-al dot terraform and dot terraform dot log dot HCL file has been created. Okay, so that dot terraform dot h log dot HCL will contains as of now which provider version is used. Okay, so then that provider hashtags, all these also it's going to store. It's not recommended to edit this file. This is automatically created um, by the Terraform itself with the init. Then you can use Terraform validate, Terraform plan. Okay, so then one resource is getting added, that is the uh, Azure RM resource group. Okay, then Terraform apply. So the Terraform apply will create the resource for that, and we need to give here yes, or you can give auto hyphen approve. Now that resource has been added. One resource has been added. Okay, so now here the cloud TF resource group in the West US2, this has been created. Now what I'll do is Terraform destroy. So the Terraform destroy will take one approval from us. Okay, so now here if I enter that yes, it is going to delete that. So now instead of only creating a resource group, I'll try to create one either Windows VM or Linux VM will provision through Terraform itself. Yeah, so now that destroyed. If I go and check in the console also, that resource has been destroyed from the Terraform wise itself. Okay, so now try to understand. Here we got the state file. Okay, so now here if I use terraform.tf state, and if any of the state file has been modified, then that first is going to store in the terraform.tf state dot backup file that is getting stored here. Terraform.tf state dot backup file it is getting stored. Okay, so then here we need to use. Like I have already main.tf here. In this workspace itself, I'm going to create Azure VM. So using that, so I'm going to provision either Linux VM or Windows VM. I can provision using Terraform. So now here we can use instead of keeping only all in the main file. Now one of the best practices we are splitting them into the like provider into one file, all resources into one file, and what are the input parameters we need to pass as variables.tf, and what are the outputs we are getting outputs.tf. So like this we are going to divide that into multiple. Folders I'm going to create. So now here in this workspace itself, okay, so now here we have like a main.tf, terraform.tf state, terraform.tf state backup. Anyhow, terraform tf state is now clean itself because it doesn't have any resources. You don't have any resources because we have destroyed the complete resources. That's the reason that file is empty. And I'm going to remove this main.tf. I'm going to create a here providers.tf. I'm going to keep one file. In this providers.tf, what I'm keeping is only which provider I want, only those details I'm going to keep this. Okay, in my providers.tf, I'm going to keep only these resources I want to keep. Okay, then I'm going to use one main.tf. in the main.tf I'm creating like again a RG kind of resource, that is a resource group, then one virtual network, what it required for my VM, one subnet in that, then public IP, network interface, and finally I'm going to attach that network interface, then storage account, Azure Windows virtual machine, all these. Like I'll explain the script, but using this we are going to create like a VM, all these, not only the VM, lot of resources, almost 10 to 15 resources we are going to create. So these all the block we are going to keep in main.tf. So provider.tf we are keeping something, and main.tf we are keeping. Okay, then what are the values we want to pass instead of using the hard coded data? We are going to use variables.tf. Okay, so which location I want, instead of using the hard coded west US like that, here I can enter that through a variables. Okay, what is the concept of the variables.tf is, like in the programming also we'll have the variables have the capability to store multiple values, depends upon the user requirement, we can create those values. Okay, then here variable prefix also, for the resource name I'm giving the prefix, but we can change these values either at the command line we can change, or we have one value like for dev I want some settings, for QA I want some settings, those all we can pass it through, we can pass it from the like we can pass it from that Terraform command line, we can pass it at the apply, or we can keep it for dev environment I want different settings, for QA environment I want different settings, we can create a different values also for that. So now here I'm creating one more file, variables.tf, variables.tf. Okay, I'm creating two variables as of now, but depends upon that, don't use the hard coded value in your main.tf. Always we need to use the variables and pass that variable name to the script. With this, what is the advantage we are going to get with the Terraform is, we are going to get more reusability for that. Okay, so we are going to get more reusability for those resources. Then here we have outputs.tf. What is the outputs is, I don't know what is the public IP for my VM, or what is the like a VM ID I'm going to get. When I'll get those details, after provisioning only I'll get. Where I can see is, I can see that in the state file, but it having a lot of details. But from that, okay, I want to store the important details. Those I'm going to create as those I'm going to declare as the output variables. So what is the difference between variables, and what is the difference between outputs? What is the difference? Variables means whatever the customized options we want, or user inputs we want, okay, for different environments, if you declare as the variables, we can pass the values. For dev environment, I want different settings. For production environment, I want different settings. For staging environment, I want different settings. Okay, then, or maybe for multiple projects also, we want to use the same Terraform scripts. Then we don't want to hard code the values. Those we are going to use like our own variables we can pass. But outputs is all the details we are storing in the Terraform state file, but I want important details. These may be the inputs for the next level of automation. So suppose what is the resource group name I'm getting, public IP address or private IP address. Like this, we can declare the output values. Okay, normally we can search all these from the Terraform show, but we have hundreds of values. But important values we are declaring as
Variables.
no output variables. Input parameters we are passing as input values, but output details we are passing as the output variables. Okay, using the variables, what we are passing are input parameters. Okay, but here output variables are after you provision the resource. Okay, whatever the values are coming are nothing but output variables. Okay, so those are called as the output variables we are calling. So now in this I'll go for these all the values we have. Okay, so now here what are the files we have is main.tf, providers.tf, outputs.tf, variables.tf, and this terraform.tf state is to maintain the state file, and we have hidden files we have is one directory dot terraform. This downloads the provider all those. Then .terraform.log.hcl file will tell which provider it need to use, minimum this version of provider. All those details have been locked in that. Okay, so these two have been created with which command? These two have been created with which command?
Which one, sir? You're asking.
Okay, so now here with the Terraform init, these two have been created. With the Terraform init, those two have been created, and state file when it is created, when we do the Terraform plan or Terraform apply, when the state file got created.
After after init,
After apply, this is created. And when, if any modifications have been performed, then terraform.tf state backup is getting created, and the recent new changes will go to terraform.tf state. Okay, so now, like after I creating all this, I'm going to initialize again. Upgrade parameter, if any new providers are required, those may be used. Okay, otherwise init itself is enough. But upgrade, what it is doing is, if any new parameters, all those need to be upgraded. If any higher version of provider comes from Terraform Azure provider, then it is going to install. Okay, so now here previously we have around 3.c something, but now it is installing another provider. According to this, it will update the terraform.log.hcl file also. Okay, now this has been initialized. Now what we are doing is in this plan, we are saving that plan also with one name. Okay, we can save that plan also. Okay, so now here Terraform plan hyphen out. Okay, I'm saving this into main.tf plan. Okay, so this output parameter we can specify an output file. Okay, and that plan we can save it. Now whenever I'm going to apply, I'm going to use that plan itself. So I'm saving all this output into main.tf plan. From the TF plan, I can provision the resources. So now that Terraform apply, what we need to do is this, from this plan I'm going to create. Even if you can later you can perform the changes, but from this plan I want to provision those resources, or directly you can use Terraform plan and apply also is fine. But normally first we are going to save that plan with that version we are creating by using that plan name. Now this will take minimum 5 to 10 minutes because we have lot of resources are getting created here. Okay, almost 13 resources manually. It will take more time to choose all this, but Terraform also will take some time to provision all this. Okay, so like this here in that main.tf, whatever the resources we have, all those are creating. Now it is creating the like a subnet, VNets, network interfaces, then storage accounts, IPs. Okay, resource group also first initially it's creating, and whatever the dependency we have between the resources, first vnet need to create or subnet need to create.
First subnet and then VNet, sir.
No, no, within the vnet we are creating the subnet.
Okay, okay. Sorry, it is a cider, right? Okay.
Yeah, yeah. So first we need a vnet. In that we are creating the subnet. That order also Terraform knows. Even in my main.tf, if I keep my subnet also initial resource, it won't create that. First it will create the First it
VNet
will
and
create the
subnet.
vnet, then only it subnet. And the resource group vnet, which resource need to be created first?
First
First resource
resource
group itself need to create. Okay, so now here, if we have the dependencies between the resources, okay, we have two types of dependencies. Okay, so two types of dependencies. What are those two types of dependencies? Is we have implicit dependency. Okay, second one is explicit dependency. What is this concept of implicit and explicit dependency is between the resource group and VNet, or between the VNet and subnet. If I go for this, by default with the Azure wise, we have already dependency between them. Okay, that means first resource group need to be created, then only like VNet need to create and VNet subnet. But if you have a storage account, okay, storage account and VM we have, by default there is no dependency between them. Okay, that means even storage account can be created before, or VM can be created before, or vice versa also is possible. But in my project, I have a storage account need to be created first. Okay, storage account need to create first. Then I want to, while creating the VM, I want to store some data in my storage account. That is my business requirement. In this scenario, that is not an implicit dependency, it's an explicit dependency, depends upon our requirement we are going to use. Okay, so that means that storage account need to create. In this use case, okay, we need to use depends on feature. In this use case, we need to use depends on feature we are going to use. Okay, so what is that meaning? Why will use depends on? In the vnet and subnet scenario, you no need to do depends on, because we have the implicit dependency between those resources. Okay, but if you have business wise any requirement is there, then in that use case, what we need to use is, okay, first which resource I want to create.
first
So uh, so here first we need to create Azure VM we need to create. Okay, after that, sorry, first I need to create a storage account, maybe blob storage, something file share. And when I'm creating that VM, I want to access that file share. Okay, then here first I need to create like a which account I need to create depends on, I need to specify. Okay, so what is the keyword I need to use?
dependency.
Depends on. Okay, for implicit dependency we are using, or explicit dependency? For implicit dependency or explicit dependency this is?
Implicit only, right?
No, no, this is explicit, because storage account VM technically we don't have any dependency like
Dependency.
we have VNet and subnet. So this is business wise explicitly we have the dependency. Okay, in that use case we need to use
Ex-
depends on. Okay,
depends on.
how implicit dependency works, I'll show you. How implicit dependency works, I'll show you. So how we are going to configure the implicit dependency, we'll try to understand by seeing this main.tf file. So here we have this main.tf, right? I recommend to use Visual Studio or Notepad++ for this. So now what is the first resource we have created here is resource group. Okay, so here we have created resource group. Okay, so then this is creating one resource group. Okay, then when I'm creating my virtual network, okay, so now here I'm using this resource group name is Azure RM underscore RG dot name I'm giving. That means Azure resource group dot RG dot name. So here, whatever the name it is coming, I not hard coded. This I'm linking. Okay. So then, when I'm creating a subnet, I'm attaching my virtual network name is. I'm not using the hard coded value. What I'm using Azure RM underscore virtual network dot my Terraform underscore network dot name. Okay. So this will tell. First, this VNet is required. Then the subnet need to be joined to this VNet. So now here we are adding this right virtual network to the subnet. This is the implicit dependency. Means this will tell to the Terraform this VNet and this subnet have been attached. And in that, definitely first it need to create the resource group, and resource group has been attached to this VNet, and this VNet has been attached to
Subnet.
subnet. And when I'm going to create that like a VM also, say here we are creating one Windows VM. In that Windows VM also, we are attaching
Storage account.
yeah, storage. Say here this is extension IAS. It's installing that. So now here we are attaching that resource group name network interface ID. Okay, in the network interface ID, they may have already attached. In the network interface ID, they have already attached the
Subnet
subnet
ID.
ID, and already to the subnet which has been attached, VNet has been attached. Okay, so these all the examples for
Implicit dependency.
implicit dependency. If you have any explicit dependency between the resources, we need to use depends on feature. Going forward, we'll create explicit dependencies also we'll use. But these all like how that we need to subnet or to the network interface and network interface to the VM, how their linking is by using the implicit dependencies. Those are connecting. Those are connecting. Still it is taking. So what this is doing is by using the virtual machine extension, it is trying to install IAS also on that VM. So we have the Windows VM, right? On the Terraform itself is going to create. Uh, so here this command is getting executed. This PowerShell command, let what it will do, it will set up the web server, and IAS management console also it is trying to install. Okay, so with this it is going to install the
Web server role.
web server role also. So for that we use the resources, not the VM. Already VM has been installed. Then after the VM is there, VM mission extension is the resource name. These all the resource block details we are getting from the Terraform provider we are getting. Okay, and what is the provider we are using here?
Azure Arm.
Azure RM is the provider name we are using. Now, like almost we have the 13 resources in our main.tf, and all these resources has been created, and we created output values, right? Otherwise, we need to see all these in the show. Terraform show will have a lot of details.
So what is the public IP address we are getting, sir? This is public
That is
IP
for
is
the
not
VM we are getting, right? But it is showing private IP. It's in 1 second. 172. Okay. No, no, 10 dot series we give for the,
missions.
yeah. So now here this is the Terraform VM, not this one.
Central India, that one
No,
only.
no.
Line, right?
With the RG group it would be there.
Yes, sir. Yes, sir.
This one, public IP. That instance, after we provision that, we are going to get that output. Okay, so now here you can see those details from Terraform show, but here we'll have some hundreds of values. Okay, in this you need to search, but if I use the output values, what we need to use in the output values is which are important. Those all the details you can specify in output values, and I'm not displaying the password because it's a sensitive value. Okay, if it is any password kind of things, that not recommended to use in the output values, because how to make it sensitive also we'll discuss, because some of the details we shouldn't show them. Okay, that is the reason we are going to keep in the sensitive value. So now here all these details have been stored, where we are going to maintain the state file, where we are going to maintain the state file. We are keeping the state file in where we are keeping the state file. We are keeping the state file locally. We are keeping, okay, but local state file is not recommended because someone other used this Terraform script itself. They deleted that resource. I don't know that resource has been got deleted. Okay, so in this kind of use cases, local state file is not recommended. We are going to use the remote backend. So we are going to use the remote backend. So what is the advantage of remote backend is if multiple admins or multiple team members are going to use the Terraform, all those changes need to be stored remotely. Everyone storing them, everyone storing them so only storing them as in the remote location we need to store. For that, what we are using is we are going to keep that state file in the one Azure account we are creating, and in that blob storage we are going to use our backend. If I don't specify uh, any remote backend is need to required, we are going to use our backend.tf we are going to create. If you don't specify anything, by default it uses the local. That's what is the problem with the local state file. Other changes are we are missing, or what are the changes we have performed others are missing. That's the reason we are going to keep in a centralized location. Okay, any doubts on that? So what is the problem with the local state file?
So we are not getting updates. People are doing updates on that
Yeah,
file.
otherwise, everyone won't get the up-to-date state file. So everyone
Sometimes
will have the
corruption also.
corrupted or maybe wrong state files only we have. Okay, that's not recommended in the enterprise environment. That's the reason we are using our remote backend. If you are using AWS, you can keep AWS S3 buckets we are going to store. But in our Azure use case, we are going to use Azure storage account we are using, and in that storage account we are going to keep those. Okay, so then for that purpose, what I'm going to do is I'm going to add a remote backend. I'm going to add to my provider itself. Okay, I'm going to add my remote backend. If I don't specify the remote backend by default, what's happening is if I don't use the remote backend, what is the default behavior with the Terraform?
Uh,
If I don't specify the remote backend, by default, it is going to use
it is created a backup.
no, locally it is going to use the state file. Okay, but now what I'm telling to my Terraform is I don't want to store that locally. I want to use my backend, and my backend is not AWS or Terraform Cloud. I'm using Azure itself as my backend. And what is the prerequisite for this is we required one storage account also we required, and one container name in that, and a key is nothing but a file in that container. The storage account we need to create a blob storage, then one container name we are giving this name. Okay, then one key, in this key that state file is getting stored. Okay, so this all I'm going to keep in one more file. Okay, that I'll keep here. We have already main.tf outputs.tf, right? Here I'm going to create one more file, backend dot tf I'm going to create. In the backend dot tf I'm going to keep this. Okay, and definitely I need to create that resource group name is already existing. Storage account name, container name I need to create either through CLI or from the GUI. I'm going to create those storage accounts. Okay, so then here I'm going to use the storage accounts.
వెళ్తున్నాం.
I'm going to create that storage account, blob storage I'm going to use. Okay, already we have the resource group, clouds of resource group is there. Then this is the storage account name I want to keep. So Cloudsoft storage account name I want to give this. If it is duplicate, you can create another one. And the primary service I want to use for blob storage. And redundancy GRS is fine or local also is fine. I'm going to create this. And to all the users also, say who are 10 employees or 20 employees we have, for all of them, for the storage account we need to give the read and write kind of permissions also, because they also want to write the state file changes. Now we are keeping centrally in the remote backend, we are going to keep that state file. Locally keeping is not an enterprise use case. So once this has been created, now like I have changed the state file from the like local backend to remote backend. Definitely that required initialization again, because all these days Terraform has been initialized with the backend is locally itself we are keeping. But now we have added a backend.tf, right? In order to reflect that one, definitely what it required is Terraform init is required again. Now it's going to initialize the backend, and which backend it is now is going to use is Azure RM. Okay, so Azure RM. Now, what is the problem here is I just created that storage account, but I didn't created that container in that. Okay, I'll go to that resource. In this, I'm going to create that container name. Whatever the container name I have given, that here I need to create a container. Okay, so now what is the name for the container we have used this? TF state is the container name. TF state. In this already that file would be created. I'm just creating that tf state. In that the file name is that key, whatever the key we have, dev dot whatever is getting is going to come into this. Now again I'll initialize this. So now it's again initializing the backend. If any of the provider has been changed, or maybe new providers have been added, or provider is getting upgraded, or like if any of the backend has been changed, it's required to we need to reinitialize our Terraform. So we need to reinitialize the Terraform. Okay, then yes. So now locking also is very important, because if that Terraform is used by one user, normally it's going to lock it. Normally it's going to lock it. Okay, so now I'll go and check that container. Df state. Okay, local one we can delete also. So acquiring state lock is like it is checking whether anyone is using in the team. Okay, if it is in the use, we can't perform those operations. Now even in that we have installed IAS also. We'll check whether that IAS has been installed or not by checking that a public IP. Now here in this key we need to get that. So what is the meaning of locking is, like if in the multi-user environment, if any of the user is using Terraform, then for the others it would be locked. For the others it would be locked, and we didn't check this IAS with the extension it has installed or not. I'll confirm that whether IAS has been installed or not. For this we need to confirm whether that NSG has opened the 80 port also. Got the access. That user have the permission for this. It's throwing some error, but actually this will be displayed for the user. We have by default that contributor role also. After some time, we'll check this. So now here this is going to be stored into this backend. Okay, so this is going to be stored in the backend, and even that security group also you check when you do this 172.174. It need to have the IAS also need to be installed. Okay, so that IAS also need to be installed, and in that security group also we need to have the 80 NSG. We need to open 80 port need to be open. Then that page we need to get that. Okay, so till this, uh, everyone practice the provisioning of resources. Okay, and try to add your remote backend also.
Okay, sir. Tomorrow we have class, sir.
Tomorrow I'll inform you. Okay,
Okay,
maybe
due to
Terraform you practice. We'll see ABD will connect tomorrow.
okay,
Okay, sure. If not there, I'll inform you.
okay, sir.
Okay,
Okay,
have a good one. Can you share all these,
sure, sure.
uh, the video and the notepad file?
Okay, I'll share that.
Thank you.
Okay, sure.
Have a great day.
That's sure. Thanks. Bye.